Welcome to another problem session. Let me close that door. Forgot to do that earlier. Okay, so here's a good problem. It's a two-pulley problem, and we are likely to encounter this in, let me see, MCAT. This pen is really getting to me. MCAT or JEE or any medical or engineering admission test. Okay, or even physics test, physics 1 test or mechanics course test. So this pulley is self-explanatory. This pulley can move. This is fixed. This one is fixed. It's not moving anywhere, but this is actually hanging. So this can move around. It will have its own acceleration. I'm going to use capital letter A for its acceleration. And this one can have accelerate up or down and use letter A1 for it. And this one can up and down one. So normally this kind of problem is what is called constraint problems. And without thinking in terms of this is a primary vehicle through which you should attack it, you are going to be not happy with the result, because it's gonna, if you guess around, it's going to be wrong. Okay, so this is the first problem we're encountering where guessing around is probably not going to be very helpful. You need some systematic approach. So one of the things would be that this string is string 1 and there's a string 2. Their lengths are fixed. So all this doesn't say in the problem. So assumption is strings are not extendable. Our strings are inextensible. This means its length is fixed while this thing is happening. I know when it was crumpled, you pulled it, it looked like it can be a little bit longer, but once it's all get going, during the time it is going, no length is changing. Okay, so length this plus around all the way here will be fixed. We will include this hanging mechanism, include as a string. Okay, just to make this calculation simpler. So this constraint problem, so this is a very interesting. Second observation is you must think of this as F equals to ma in vector form. So one way to do it is like thinking of this will be like fx equals to max, fy equals to may, fz equals to maz. So this is important thinking here. Of course, this is important in almost every ethical science problems. We have done several in this series already. So this is very important. Here we're just going to be dealing with this. So I'm going to just, because I'm going to deal with this, I'm going to drop this, drop from this problem. So we're not going to have this, we're not going to have that. We're going to just write A for AY, and you'll see why. So let's pick a coordinate system. So this is X direction, and this is the Y direction, and this is going to be the origin. So this guy is some Y1, This guy is some y0. You're not going to put 0 there. This guy, this thing is some y. Let's call it y. And this will be y2. So this is time independent, this is time dependent, this is time dependent, and this is time dependent. So we'll have a y1, y, and y2, and then v1y, we're going to write just v1 using that notation. And its velocity will be vy. We're just going to write v. And this will be v2. I'm just going to write v. v2y will be just v2. So the way you're going to go from here to here is d dt. Take time derivative of this, gives you this. Time derivative of this gives you this. From here, I'm going to have acceleration a1 y. I'm going to just keep it like that for now. And ay, and this will be a2y. Okay, so what do we mean by constraint? Constraint will be, so let's go back to what the constraint means. Here turns out constraint is in this, and they're not all independent. Actually, there's only one of them is independent. Everything else can be found from the other. So let's look at string 1. A string, and let's call this radius r. So string 1 is, this part is y0 minus y1. So you have y0 minus y1. So this is a function of time. Add that to pi r part. To that, add from here all the way here y0 minus y1 y plus y0 minus y. This is L1. Of course, if I take its ddt, then it's going to be minus v1y, this is 0, plus 0, plus 0, minus vy equal to 0. So this is just telling me vy is equal to minus v1y. So that's their velocity related. Take a ddt again. So this one is give me ay. And we were going to write like a capital A, and this is going to be equals to minus a1y. So we were going to write it a equals minus a1. We are dropping, and this one we would not need this to solve this problem, but it will be v equals to minus v1. So we're going to write like this. We're going to drop y's for simplicity, but we know its component, okay? So if you do numerical value, if this is positive, then it's pointed up. If it's negative, then pointed down. So because we're not going to do numerical. So now let's look at, so we have, this is important because we are not working with these guys. String 2, pause the button and actually try to figure out what the string 2 will be. Okay, so I'm going to continue with string 2. It's going to be, this is the string all the way here. So you'll have this part is going to be from here up to here. That's just y of t. So that part. Plus I'm go around this pi r. we're going to take both of these pulleys same for simplicity, because it doesn't make a difference anyway here. And so all the way here, from here to here is going to be y minus y2, yt minus y2t. And this is going to be length of the second string. Now, to do the same thing, is going to be vy plus 0 plus vy minus v2y equal to 0. So this is just going to be 2vy equals to v2. Take a time derivative again. So this is 1 ddt. Do another ddt. 2ay equals to v2y. And we are writing a for that, and we're going to write a2y. Taking the time derivative of that to get the acceleration. So we're going to just use this. So these are two constraints equation, 1 and 2. So let's say if we wanted to find a1, then when we write equation, we're going to write everything in terms of a1. Try to get rid of this. Try to get this guy and this guy, and write everything a1. Say. So next step is to write f equals ma for f equals ma, f equals to may for m1 pulley. All this mass is pulley. I'm going to use this, but this is 0. Mass is 0 doesn't mean it doesn't have acceleration, okay? And m2. So let's try to write that. So thinking of this, of course this guy acceleration is 0, so don't need that pulley. When you say pulley, meaning this one, okay? So this one, if you look at this in isolation, there are only two forces on it, and this string is going over that. So this string will have one single tension. Why? Because of this pulley being massless and frictionless, then this whole thing will just have one tension. So let's call it tension for the pulley string 1. So tension for the 1. By the same argument, we will need this. So let's work this out also. This string will have tension same in the string. These two strings are different, so they will have two different tensions. They may turn out to be equal to each other, but we shouldn't assume that. Now, if the pulleys were not massless and frictionless, then these tension on this side may not be the same as that. Tension on this side may not be that. But since we have this assumption, we can simplify it and use that simplification. So working out that mass, so for the M1, free body diagram for everyone, so it just looks like this. For pulley, it looks like this, and M2 looks like this. So these are the free body diagrams. All right, so in this thing, you already can tell this is going to be tension 1 and mg, and y-axis point that way, and we're using acceleration a1. A1y doesn't matter, this we don't care. This we are calling it a1. For this guy, you have tension 1, because this is the same string as that string. These strings are same. You have tension 2, this side tension 2. Remember, tension pulls away from the free body. The body that you're looking at, tension is pulling that away. Okay, so over here, tension is up. Tension is up here too, because this is the body, but these tensors are down. And then will be MPG, and you will also have a normal force that will be supporting it, right? Right? What do you think? There will be no force there? No, because that's included in this already. That's included in this tension. So you don't have that force. Okay. So over here, this will be this is string. So it's going to be T2 and M2G. Now this is going to be 0 because mass of the pulley is 0. So that's so let's acceleration of y-axis is this way, and AY we're writing capital A. Y-axis this way, A2y we're writing as A2. Okay, let's write all this. I'm going to use black ink for now. So this one is going to be T1 because this is positive. So going to be T1. This will be negative minus M2G. This will be negative over there times M2 times this acceleration symbol is just A1. I would have written this symbol, but I'm just going to use that, right? It's question 3. This one will be T1 positive, so T1 minus T2 minus T2 minus T2 minus T2, this is 0 equals MP, its acceleration, but this is 0. So this is equation number 4. This guy is again y-axis that way. So T2 minus M2G equals M2 A2Y, but that's A2 we're writing. So let's see. This 1, 2, 3, 4, 5 is enough to solve for. Symbols are A1, A2, A, T1, T2. These things we don't know. We have 5 questions. We can eliminate, get all the information we want. Okay, so maybe you can pause the video and can do it your own way. I can just continue. Okay. So clearly we didn't need that except for here. So let me write down using 1. See, in these equations, capital A didn't come up, but this A is minus A1. So A2 equals to minus 2A1. So from 1 inside here gives me this. And so this will become minus 2M2A1. So we got rid of A2. We don't have, now we can get rid of T2, or we can get rid of T1. So T1 equals to 2T2. So now plugged in here, let's get rid of T1. So 2T2 minus M2G is M2A1. So we T2 minus M2G. Between this and this, let's get rid of T2. To get rid of T2, I need to multiply this guy by 2. So 2T2 minus 2M2G equals to minus 4M2A1. So between this and this, let's subtract this guy. So you got a minus M. This definitely was not correct. This was M1. So this is M1, M1, M1. T1 is correct. This is M1. So minus M1G on the other side is M1 from this equation, because this guy will cancel that guy. This will become plus 2 M2G, and that becomes a plus 4 M2A1. So this side simplifies like M1 plus 4 M2 A1. M1 to A1, the A1 will be 2M2 minus M1 over M1 plus 4M2. Ratio of these masses times G. Found A1. Clearly is saying that, say, interpreting will be if M1 is 2M2, then A1 is 0. If A1 is 0, then A is 0. If A is 0, A2 is 0. This just means everybody, no acceleration. A is 0, A2 is 0. So the balancing condition would be this mass and this mass, what is their ratio? And that this arrangement of pulleys actually, because you have two of these balancing one of that, you need 2 times M2 to balance one mass. That's pretty cool. Okay, so now of course, you can say what is A2? It is very simple. We already know minus 2A1. Minus 2 times what's A is minus 1 times this stuff. So you don't want to write this down. So what is tension? Well, I can get tension from here. So tension in the 1 is M1 times this stuff 2M2 minus M1 over M1 plus 4M2 G plus M1G. So if you do this out, M1G is common, M1G is common, so 1 plus 2M2 minus M1 over M1 plus 4M2. And so you can simplify it, and T2 will be half of T1. T2 will be half of T1. Okay, that's it. So we've done this problem, and you may try to think of more variations of this. We are going to be pretty much moving on from pulley to some other types of problems. I was thinking I would do one more constraint problem in the future video. Till then, take care. Bye.